now we are ready to integrate trig functions. And so there's a strategy to this. And so I have it listed on the worksheet. It says if you're integrating something of the form sine to a power times cosine to a power, where m and n are positive integers, if the cosine is an odd power, then save a cosine and rewrite the rest in terms of sine. If sine is an odd power, save the sine and rewrite the rest in terms of cosine. How are you going to rewrite these guys? Using some trig identities that you learned a while ago. So that's how you're going to rewrite it. And as we saw in the last video, when we had to integrate sine x, cosine x, we used a trig identity to, I believe that was a double angle identity to rewrite it. So we have those we're going to use. If both of the powers are even, we're going to have to use one of these identities. Okay, so these are the identities we're going to be using. This is the strategy we're going to be using. So let's just dive into it and see how it goes. Here is example 1. We're going to integrate cosine cubed x. Okay, this is a cosine with an odd power. I'm going to save a cosine. This is how you save one. We'll rewrite this into the cosine of x times the cosine squared of x dx. Okay, this is the one I'm going to save. All right, this is the one I'm going to rewrite. How am I going to rewrite him? I'm going to rewrite him using the Pythagorean identity. Sine squared x plus cosine squared x is 1. So I want to rewrite this in terms of sine. So that 1 minus sine squared x dx. Now I can use u substitution, no problem, to get through this. Let's let u be sine x, right? Then du is the cosine of x dx. So if we rewrite this in terms of u, just by writing down du, we took care of cosine x dx. And now what we're left with is 1 minus u squared. And we can integrate this, no problem. The integration of 1 would be u minus, this is going to be u cubed over 3 plus a constant. Put everybody back in terms of the original variable. We get sine x, that's what u was, sine x minus 1/3 sine cubed of x plus a constant. All right, that's the first example. Let's do this one right here. Sine to the 5th of x times cosine squared of x. Sine is being raised to an odd power. Save a sine. So that's fine. Here we're going to save this guy. Sine x, we'll save him. And then the rest of this we'll rewrite. I have sine to the 4th x is left times the cosine squared of x dx. Now, I want to rewrite everybody else in terms of cosine. Sine to the 4th of x is the same thing as sine squared of x squared. And sine squared of x can be rewritten as 1 minus the cosine squared of x. So what I'm going to rewrite this as is the integral of sine of x times 1 minus the cosine squared of x quantity squared times the cosine squared of x dx. So let me clean this up. If I square this, this becomes 1 minus 2 cosine squared of x plus cosine to the 4th of x times cosine squared of x dx. Copy over your sine x. So then I'm going to distribute my cosine squared of x. So this is going to become the integral of the sine of x times cosine squared x minus 2 cosine to the 4th of x plus cosine to the 6th of x dx. Now we can use u substitution. Let's let u be cosine and du will be our sine x, and that will take care of that. U is cosine. Du is the sine x dx. Oh, except for that's a negative, right? So now negative du is sine x dx. So I'm going to rewrite it up here in terms of u. So I'm writing all this in terms of u by writing down negative du. What did I get by writing down negative du? Well, I got the sine x and the dx. The rest is this stuff. So I have to accomplish that by writing u squared minus 2u to the fourth minus 2u to the fourth plus u to the sixth plus u to the sixth du. All right, let's just integrate power rule. This becomes negative 1/3 u cubed plus, negative times negative is plus, 2/5 u to the fifth minus 1/7 u to the seventh. Rewrite everybody back in terms of the original variable. So where did I make my substitution? U is equal to cosine. So this is negative 1/3 cosine cubed x plus 2/5 cosine to the fifth x minus 1/7 cosine to the seventh x. I forgot my constant, plus a constant. That is what we get. Let me check and make sure I'm happy with my answer. Negative 1/3 cosine cubed plus 2/5 cosine to the fifth minus 1/7 cosine seventh. Yep, that's a good one. All right, 2 more examples. Let's see here. The next one is, it has limits on it. So how do we deal with that? And it's the sine squared. Yeah. So that sine squared is just a little bit difficult because, you know, you let u be sine, then the derivative is cosine, and we don't have a cosine to help us with that. So what will we do here? So we're going to have to go down and use an identity for this one. So for number 3, the integral from 0 to pi of sine squared of x dx. 0 to pi sine squared x dx. Well, what can we do with that guy? Let's go use this identity right there. That's going to help us a lot. So, and we already saw how to handle when we're integrating the cosine of 2x. So let's deal with that. Let's just rewrite this as the integral from 0 to pi of 1/2 times 1 minus the cosine of 2x dx. We can integrate this. This is not a problem. I'm going to push the 1/2 on the outside. 0 to pi of 1 minus the cosine of 2x dx. The integral of 1 is x. The integral of cosine 2x is sine 2x, and we make that adjustment by putting a 1/2 right there. This was the 1/2 is still out here. So this is this 1/2, right? What did I do? I integrated 1, I got x. I integrated the cosine of 2x. Okay, integrating cosine, you get sine, so it's minus sine of whatever, but then we make that adjustment with 1/2. Now what I didn't do was let u equal to 2x and use u substitution, but you could use u substitution to make sure you're understanding that, and you should. If you are not like seeing that, just go ahead and do the u substitution and you'll get that. All right, now we're ready to integrate at the limits, or evaluate at the limits now that we've integrated. So this is going to be 1/2 times whatever happens in here. So let's see, let me put a little brace in there. So this is going to be pi minus 1/2 the sine of 2 pi minus 0 minus 1/2 the sine of 2 times 0. All right, the sine of 0 is 0, this is 0, this is a big 0. The sine of 2 pi is 0, so I'm left with just 1/2 times pi, or pi over 2 is my answer to number 3. All right, number 4. What do we do when we have sine to the 4th? So we're going to integrate sine to the 1/4 of x dx. What are we going to do with that? Okay. We're going to rewrite using this identity. Okay, so let's see what happens here. When we integrate this, we're going to say, oh, this is equal to, we're going to think of this as sine squared of x squared. Okay, so we're going to think, so I'm going to rewrite sine squared of x as this right here. Right? So this is equal to 1/2 1 minus the cosine of 2x squared. Sine squared x is equal to this, and it was being squared. All right, so let's go ahead and deal with this. I'm going to distribute the 1/2. 1/2 minus 1/2 the cosine of 2x squared. Now I'm going to square this. All right, so this is going to be the integral of 1/4 minus, you know, should I leave the 1/2 out there? I think that'd be easier. I'm going to leave the 1/2 out here. Sorry. I think that's easier. Let's do that. Let's leave the 1/2 out there. All right. Square this. 1/4. Square this. Okay. That's going to be a 1 minus 2 cosine of 2x plus cosine squared of 2x. Okay, that's better. dx. Right, that's okay. Now, this cosine squared of 2x needs to be rewritten using this right here. We're going to rewrite that guy. So, hang in there. We're almost done. Let's do that and make a little more. This is going to be cosine squared of 2x. Let's think about this. Can be rewritten as 1/2 the cosine of 2x. But our x is a 2x. So when we rewrite this, it's careful. This is going to turn into, let me change colors. This is going to turn into 1/2 times 1 plus the cosine of 2 times the angle. But the angle was 2x, so this turns into a 4x. Be a little careful there. All right, so what have we got? We've got this 1/4. I'm going to put it on the outside of this whole integral. That will take care of that. We've got this times 1 minus 2 cosine of 2x plus, I rewrote that. There. All right, this is what we got, dx. We can do this. Let's distribute the 1/2. 1/4 stays out here. We've got 1 minus 2 cosine of 2x plus 1/2 times 1 plus 1/2 times the cosine, 4x. All of this is in the same big integral. Okay, here we go. 1 plus 1/2 is 1.5 or 3/2. So let's do that. This is the 1/4 on the outside. This is the number 3. Oops, 3/2. I just added this plus this together. Okay, then I have minus 2 cosine of 2x plus 1/2 cosine 4x. dx. Yay. Okay, so here we go. 1/4 integrate 3/2 x minus 2 integrate. The integral of cosine is sine, so it's going to be sine of 2x, but we adjust it by dividing it by 2 because of that angle, okay? Plus 1/2. This is going to be sine of 4x when we integrate, sine of 4x, but we adjust it by dividing by 4 times 1/4. And then we have a plus a constant right there, and that's it. This is all times 1/4. Oh, no. What? No, do we have limits or do we not have limits? No limits. No, it is plus a constant. Plus a constant. All right, so here we go. Let's distribute the 1/4. 3 times 1 is 3. 4 times 2 is 8 times the x. Good. This is a 1. All right, that's a 1. So we get minus 1/4 the sine of 2x. Okay. This is a 1 over 8 times a 4. 8 times 4 is 32. Sine of 4x plus a constant. Let's just check it. 3/8 x minus 1/4. Sine of 2x plus 1 over 32. Sine of 4x plus a constant. Okay, that's it. So this is just showing you, hey, sometimes you got to dig deep and use some things, and sometimes you got to use it more than once. So we're going to be really good at integrating very soon.